Hello, everyone. So welcome today to our new session in How to Interest Group. So today I'm happy to welcome Alyson and Cleft. So Alyson is a research technician at Selmap and COSM. Cleft is software engineer at Sulfate Lab. And today they will teach us how to use Pantera from developer side and from annotator side. And we can start. That's like.
Cool, yeah, thanks. So Pantera is a 3D annotation and visualization tool developed primarily the developer right now, with contributions from obviously everyone in the Self Lab, particularly Philip and Igor in the past. So for the beginning portion, I'm going to hand it over to Alyson. She's going to show you some of how she uses Paintera and some of the features that she uses to annotate, and then after she's done, I'll come back and I'll talk some about the other features, some of the newer features that have been developed, and yeah, we'll be open for questions as well. So with that, Alyson, thanks.
Thanks, Caleb. So I'm going to break the rules just a little bit and start with a presentation just to give you some context behind the step-by-step tutorial I'm going to go through. There's a lot of different ways to use Paintera for many different applications, and the Selmap pipeline is going to incorporate this application and how things are specifically imported and annotated. And I also just want to show you kind of some real-world examples of how Paintera has impacted Selmap automatic segmentation success. So with that, we'll get started. All right, so as a Selmap annotator, I work along with the ANA annotation team to generate manual segmentations for use as ground truth in automatic segmentation machine learning experiments. And up to this point, we have often relied on high resolution, small volumes for most of our ground truth training data. And while this is helpful because you input a lot of dense, highly detailed ground truth, there's a lot of context missing. And so oftentimes larger structures, larger volumes, different cell types, especially in tissue data, are not predicted on as well just because context is missing. In addition to that, a lot of the annotation software that we've used up to this point has been orthogonal view based, and we have annotated across the imaged planes. And while this often is sufficient for certain organelles, there's a lot of staining that is missed when you don't have access to rotational views, especially when you're looking at smaller connections between organelle systems. So Paintera actually solves these issues for us. So how is Paintera used in the Selmap pipeline? So first and foremost, we can visualize whole cell and tissue FibCen multi-resolution data. And this is helpful for picking out regions of interest, for looking at interesting features in various data sets. Another big help from Paintera is the rotational views, as I mentioned before. And this is primarily to provide more context to annotators so we can get more standardized and more informed annotations. Another feature that Paintera provides, and something that I'll be able to show more concrete examples of in the next slide, are low resolution annotations, which have provided more context for training networks. And this has greatly impacted the accuracy and performance of our automatic segmentations. And finally, the import of ground truth and prediction label data sets for viewing, editing, and refinements has been made possible by Paintera. So this is helpful when we want to exchange annotations from one software to the next. If we're doing high resolution annotations in another software, and we want to just get a little more context for those detailed annotations, we can bring it over to Paintera and do some cool things with that. We can also look at view predictions in Paintera as well, and look at what types of refinements can be applied. So here is an example of some how low resolution annotations in Paintera have greatly improved some of the training models that we've used on tissue data. So on the left, you see some mouse kidney tissue. And for both images that you're seeing, both the lower saturated and higher saturated image that's overlaying, the nuclei are in pink and the mitochondria are in blue. And you can see that beforehand, we used exclusively high resolution, small volumes to train. And we used those training models on kind of naively on these tissue data sets. And you can see there's a lot of false positives. There's some nuclei labeling around some cell plasma membranes. And if we take the low resolution Paintera annotations and exclusively train with those, we actually get a much cleaner picture. We get less false positives, as you can see on the left, with the mitochondria, much cleaner boundaries with the nuclei. Similar situation with the mouse liver tissue. We get more filled in mitochondria as well as nuclei. So once again, just having this tool to make more efficient, lower resolution annotations has already come into play in a big way for the CellMap pipeline. All right, so enough context. Now, here's kind of the outline for the Paintera tutorial. So first, we're going to just walk through Paintera installation, what Paintera updates would look like. And this is all done using Anaconda. We're going to learn how to create and open Paintera projects. And we're going to do this multiple times to run through multiple applications. And each Paintera project is we're going to import and view different types of raw data and label data. So far in the CellMap pipeline, we will upload cropped raw data files in HDF5 format, buffer label data sets from other annotation software, also HDF5, as well as full-size raw data sets for visualization. And those are in a Paintera-friendly N5 format. And then for files that don't necessarily have the exact same data structure as Paintera, but are very similar to N5 structure, we can use a Paintera format conversion script. And then we're going to do a quick interface overview, just take a look at an empty Paintera project, see visualization settings, different source settings, both raw and label, and we're going to learn how to create new label sources. And then we're going to jump right into annotation. We're going to look at general tools, how they can be used in what I call standard mode, which is usually what you'd use for detailed annotation and visualization. And then we're also going to look at shape interpolation mode, which has changed and improved greatly with the last Paintera update. And that can be used for the bulk annotation. And then we're going to finally cover fragment and segment IDs and how we've applied those in the CellMap pipeline, committing labels to Canvas so that they automatically save to your N5-based Paintera project. And then we'll look at an interesting tool called the replacement tool and how that can be applied to existing labels. All right, so first what I'm going to do is bring up an empty Anaconda prompt. And first what we want to do before we install Paintera is create an environment. So I'm going to create an environment called Paintera test. All right, so now we're going to activate this environment before we install Paintera. sorry. Okay, so now we're going to use the command conda install, and we're going to use the conda forge channel. Install Pantera. All right, great. So now we're in our environment. We now have Paintera installed and ready to go. In the future, if there's a new version of Paintera that comes out, we just simply run this command, similar to the installation. And since we're already up to date, it quickly gives us that feedback. And if you ever want to check which Paintera version you're working with, you can always check in the command line. All right, so we're working with the most up-to-date version. So now we're going to open a new Paintera project. And you have two options here. You can either open a completely empty project, which will inevitably, you'll save your new label data sets in one pathway, and you'll have to save the Paintera project later in a separate pathway. Or what is probably best practice is to specify your Paintera project N5 ahead of time. So I'm just going to install or open a Paintera project in a specific directory so that both the project and the labels are saved in the same place. Okay, so now I'm going to open, you can open Paintera by just entering Paintera as a command. And in this case, I want to specify the name of my new project. So I'm going to test.n5 to create a new N5 container. All right, here's a splash screen. And now you see that we have an empty Paintera project. And you can see there are 3 empty windows as well as where the 3D visualization will be. So before we add any raw data, we can take a look at kind of some general settings. So if I select P on the keyboard, we come up with a settings bar, and under here is where you will find your sources when we upload them or create them. Under the settings tab is where you'll find various navigation tools and visual settings. So you can edit features of the 3D viewer. You can also edit how the orthogonal views look. Each orthogonal view will appear in one of these 3 screens. You can toggle and change the appearance of the crosshair. There's a scale bar that will be associated with any metadata that you import from the raw data. Screen scales can be used to adjust how your raw data is moved and dragged across the screen. So yeah, now that we have covered those a bit, let's first open some N5 full-size raw data sets. So you want to go to File, Open, Raw Label Source. And in this case, I'm going to look for an N5 container. So I want to select Browse Folders. And I'm just going to open one of our data sets. I'll select this whole cell Sum 159 data set. And once I select that, this data set button is going to populate. And if I click the drop down, you'll see that it recognizes there is a raw data set included. And when I select that, the type button over here will either populate to raw or label, depending on if any label data is recognized based on the present metadata. And you can also see that the resolution has populated as well as the dimensions. So I'm just going to Go ahead and click OK. And now we have our first source, and this is essentially our reference source. All right, so now I'm going to zoom in a bit by using the arrow keys. I can also use arrow keys in different orthogonal planes to navigate. And I can also click and drag by using both mouse keys. All right, so we're zooming in. And you can also use the keyboard to scroll directly through a plane. You can use the period and comma keys to slowly scroll. If you're using your mouse, you can use the wheel. And then if you hold down Shift with either of those functions, then you can scroll faster. And it's a great feature to have these 3 orthogonal planes in view, because this will come in very handy during shape interpolation of labels. Okay, so now that we have a source, we can look under settings for that specific source. And I'm going to go under color conversion, and this is where you can edit the data contrast. And I'm actually just going to flip this contrast, make it a bit more readable. Okay. And as we zoom in, we'll gather greater detail because this is a multi-resolution data set. And as you can see down in the 3D viewer, we see the orthogonal planes all intersecting, which will again come in quite handy when we add label data. Okay, so that's a general overview of kind of the interface. And now we're going to close out of this project. So since we don't have any labels to commit to the canvas right now, I'm going to go ahead and hit Control Save. And we've already specified a directory in which the project will be saved. So now we can close out, and we're prompted if we want to save again. So I'll hit Save and Quit. Okay, so now what we're going to do is open some cropped raw data as an HDF5 file. And this is something that we do in CellMath because as easy as it is to annotate full N5 data sets in Paintera, oftentimes we don't need to import that much data. And so we'll often default to a relatively smaller crop, although it is still fairly large. So what we're going to do now is open a new project. I'll call this cropped labels.n5. Okay. So in order to create these cropped raw data volumes, what we'll do is take a H5 conversion script, and this is generally what it looks like, and we'll run it in Fiji. So we can specify the coordinates that we prefer, what resolution based on the multi-res data, the offset if necessary, if we're looking for a buffer, which we will use in the Amira-based labels later. And then we'll output this H5 file to a directory, and we'll ensure that there is metadata included so that it can be recognized by Paintera. So I already have a cropped H5 file ready. So when we're opening H5 data, we want to go to Browse Files. Here's my H5 file. And once again, it populates. And there's only one data set in this H5 file. So I'm going to select that. And once again, the type populates to raw. You can manually switch it to label if preferred. The resolution has also populated as well as the dimensions. Okay. So now we can talk a bit about how to create a new label data set and how to use some of these annotation tools. So as you can see, once again, now that we've uploaded the raw H5 file, we have a raw source. And in order to create labels, we want to use Control-Shift-N, and this will create a new label data set. And I want to save this under the current project N5 container, and I'm going to call the labels test, and the name of the data set will populate as well. And I'm just going to use the same exact dimensions as the existing raw source. And I'm going to hit create. And as you can see, we now have another source, and this is our new label source. Okay, so just a quick summary of all these settings under a label source. We also have color conversion. One of the most important settings for each label data set is the fragment selection. This is going to tell you what fragment and segment ID you are annotating with. And this is important when it comes to keeping different organelles and structures separate so that they can later be selected independently or selected as a group. And we'll go over that a bit later. We also have some mesh settings that you can use. There is currently no global smoothing tool available for Paintera, but you can use the 3D mesh smoothing scales to visualize how the data will generally look. We also have the assignments tab and a manual way to adjust the brush size. And we have metadata that you can also visualize in the attributes file under each Pantera project. Okay, so before you start labeling and after you've created your first label data set, you want to make sure that that label data set is selected, and you use this little button to select between raw and label sources. You can also toggle on and off the eye to remove or add visibility to each source. And you can even delete and add sources along the way by using the X button. All right, so another feature to mention before we get started is minimizing and maximizing these different views. You can use M on the keyboard to select an orthogonal plane to focus on. You can also use Shift M if you want to include the 3D viewer along with that orthogonal plane. In this case, I'm going to remove the crosshairs. Okay, so now what I'm going to do is zoom into a region that I want to start annotating. So now that I have my label source selected, I'm going to hit N on the keyboard, and automatically, as you can see on the right, the fragment selection window has populated. If I want to select the background label, I would double click and a window would pop up on last selection, and I would change the fragment to 0, and I would select set. And as you can see, the entire background is considered a label in the label source. And this will come in handy sometimes if you want to paint with background label to committed labels. But I'm just going to go back to the new fragment ID that I just generated. And as you can see, there is nothing there, but now we know what fragment ID we will be painting with. If there's no fragment ID selected, then you will not be able to paint. So if I hold down space, you now see that there's a little brush, and I can do a couple things with the brush. I can use the mouse to increase or decrease the brush size. I can also hold down space and shift and scroll to adjust the depth as well. All right, so now I'll do just some simple annotations by holding down the space bar and clicking and dragging with the left mouse button. So as you can see, as I was painting, the brush did not adjust to the data resolution until I clicked release. And now you can see that it is adjusted. And so what I can do now in order to erase what I just annotated, I can hold down the space bar and right click and drag to erase. And if I want to rotate and annotate in a non-orthogonal view, I can do that as well. And as you can see, the brush resolution will not adjust until I release the brush, and it will adapt to the data. Another feature that I can use here, I can select Shift-Z, and it'll reset the orthogonal planes. And now if I want to fill in a selection, I can paint on the perimeter of an organelle, and I can hold down F and click, and it'll flood fill my selection. Okay, so that's a little bit of the standard mode where it's we can do some more detailed annotations, but if you want to annotate in bulk, there is a shape interpolation mode where you can paint and interpolate at the same time. So in order to do that, we're going to hit S. And as you can see on the side, the settings bar has been grayed out and the fragment selection ID has changed. And this is not because you are now painting with a new fragment ID. It is because there is a temporary ID assigned during shape interpolation that will reassign anything you use in interpolation mode back to your original fragment ID. So in this case, I'm going to paint as if I was in standard mode. And I'm just going to paint one slice. And as you can see, if I center this selection in the middle of the screen, I can then view the same annotation in the different orthogonal planes. And as you can see, there's a bit of leftover annotation that was made before going into shape interpolation, and this will not be affected at all by when generating interpolations. So now that I have my first slice, I'm going to scroll along the same plane, and I'm going to paint another slice. And once I release, an interpolation will be generated, as you can see in the right and bottom planes. And I can continue doing this across the entire structure. There is no flood fill feature in shape interpolation mode, but there are workarounds that are actually much more efficient than flood fill that I will talk about in a second. Okay, so now that I've interpolated across a few slices and I've gotten a decent amount of this specific structure filled in, I can look at the other planes and see that there's some irregularity, some false positive annotations on the outside. The perimeter is not as clean as I'd like. So what I can actually do, instead of going to each individual slice and editing out what I want, I can go to one point in the interpolation and I can erase an exterior portion of the structure. And you'll see that the interpolation automatically adjusted after erasing some extra label. I'll do the same thing over here. And once I release, The interpolation adjusts again. I'll go out to the edge, it's a little bit more. And this is a very helpful tool because instead of going back, flood filling independent slices, you can just interpolate all the way across and make very quick edits without the need for flood fill. Another option when it comes to shape interpolation is I can hide, toggle on and off the interpolation itself by selecting Control P. And as you can see in the orthogonal planes, it only shows the slices that I have manually generated. And the benefit to this is I can go to a particular slice and select delete. And I can add an adjustment to that interpolation. So again, if I go to, once I have an interpolation, I can either press Escape to not include the interpolation to the labels, or I can press Enter to add it. So in this case, I'm going to make some labels outside of interpolation mode. And then if I go and hit S into interpolation mode, I'm just going to start painting again. And hit Control P. And toggle it on and off to view the interpolation. And I can hit Enter to add it to the existing fragment ID I had outside of shape interpolation. So as you can see, the ID that was assigned during shape interpolation has now been assigned to the current fragment ID. If, for example, I want to work on a different structure, I can hit N again. And you can see that a new fragment ID, an associated segment ID, was generated. And it'll often be a different color, just to visually indicate that it is a new fragment ID. And a rule of thumb, especially in the cell map pipeline, is to make sure that only one fragment ID and associated segment ID are assigned to one organelle or structure, as well as ensuring that there's not a single shared fragment ID across multiple structures. So I'm just keeping one fragment ID per structure. If I go into interpolation mode, I can continue adding with that new fragment. And again, you see that there is a temporary ID assigned. Another tool I can use for interpolation is toggling across manually annotated slices. So for example, I probably have about 4 slices that I manually annotated here. So I can go from 0 to 1 to go from the first slice to the last slice involved in the interpolation. I can use the left and right arrow keys to scroll through each slice. And this is helpful when you want to view if there are any slices that you want to remove from interpolation, so that they're interpolated across, or if you want to edit any manual slices. In this case, I do want to edit this one. And again, the interpolation automatically adjusts. And I'll hit enter, and it'll once again be reassigned to the last selected fragment ID. All right, so I'm just going to add maybe one more fragment ID, and then we'll talk a bit about how to merge fragment IDs and commit labels. So I'm going to hit N one more time. Again, you see that the fragment ID is updated. And I'm going to hit S. And once again, you can see that this manual annotation that I did outside of shape interpolation mode will not be involved in the interpolation.
Or something happens during a live demo, right?
Usually it can happen because of Zoom. I
Yeah.
had a lot of time that crash because of Zoom.
Yeah.
No
Yeah.
worries, we can just reopen the project. All right, so this is a good time to show how you can open an existing project. So if I go to the command line, and I want to ensure that I'm in the correct directory. Otherwise, if I type the name of the existing Paintera project and I'm in the wrong directory, it won't recognize to pull from that specific project. So I'm going to open my old project. I'm going to hit ignore lock. The splash screen comes up. And unfortunately, this is what happens when you don't commit labels. Because when you don't commit labels, they're not directly written to the Paintera project itself. So that is no problem. What we're going to do is open the raw label source again, and we can go to the recent tab. And I'm just going to select the H5 file that we're using before. I'm going to create the new label data set, Control-Shift-N. Let's try another. So now I'm going to toggle on the settings bar using P. I'm going to select my label source. I'm going to remove the crosshairs for now. All right, so let's talk a bit about committing labels. So as you can see, if I try to paint without hitting N and creating a new label ID, it won't let me because I haven't selected or added another label. So I'm going to hit N. All right, so now, as you can see, if we keep an eye on our fragment selection, here is one of our fragment IDs. I'm going to hit N again, make another one nearby. Again. Let's fill this one. Okay, so as you make new label IDs, you can go back and manually select those label IDs for further editing, or you can go again to this column and specify which ID that you either want to select instead of the last selected ID or append to the existing selections. All right, so what I'm going to do now to commit these labels to the canvas and commit them to the N5 Paintera project, I'm going to hit Control-C, And it's just ensuring that I want to commit any uncommitted labels. So I'm going to hit commit. And I get a message that the canvas has been updated. I'm going to select OK. All right, so now these have been committed so that once I close out of the project, they're already saved in the N5 folder. All right, so now that we have kind of a general sense of how to annotate in Paintera, what we can now do is take a look at bringing in annotations from different annotation software and using a tool called the restriction tool. So I'm going to close out of this project and save and quit. And if I don't have, if I haven't committed some labels to the project, I will be prompted with this screen. So then it'll already commit those labels for me if I choose to do so. All right. All right, so now what we're going to do is open a H5 folder that has both a pre-existing label data set and raw label set, or raw data set. So what I'm going to do is create a new Paintera project. Call this labels.n5. All right, so once again, similar to our crop raw data script that we use in Fiji, we have a very similar script that will include not only the buffered raw data that we select from the data set, it'll also include a TIFF file from an outside annotation software that we overlay on top of the buffered raw data. So I've already made one, and I'm going to import that. So I'm just going to go to Find, Files, since it's an H5 file. And I'm going to go under the Buffered and Mirror Labels folder. And as you can see, the dataset button populated, and now it shows that there are two datasets that it recognized in the H5 file. So I'm going to first load the raw data set, and that'll essentially be the source in which other labels and created label data sets will reference. And it correctly populated to raw, all the other metadata populated. Once again, I can go over here and I can edit the color conversion. All right, so now I'm going to go back into File, Open, Raw Label Source, and now I'm going to select the label data set. And as you can see, the type button correctly populated because some of the metadata indicates that it is, in fact, a label data set. And the resolution is half the size of the raw data, which is typical of annotations that we run, high resolution annotations that we run in Amira. And in this case, you're just going to select OK. So I'm just going to zoom in here. And here's an example of when you can use Paintera to edit and view existing labels that were not generated directly in Paintera. And the cool thing about this is it views these labels as just another label source, and you can go into fragment selection, make sure that your label source is selected, and I can select any of these label IDs, and they do have their own designated fragment and associated segment ID. And I can go ahead and edit any of these labels. And again, they won't be committed to the H5 file or project canvas unless I commit them by using Control-C. And so now the final tool that I'm going to demo is the restriction tool. And this tool is great if you already have segmented labels, but you have mislabeled them or they're labeled under an ID that you want to change. So in this case, I'm going to find a point where, in this example, I want all of these clusters that are right now labeled as exit sites to be labeled as ER or any other ID. So what I'm going to do, for example, I'm going to select the ID that I would like to use to paint over these IDs. And I'm going to actually go into interpolation mode. And I'm going to start painting over the structures that I'd like to incorporate with this label. All right. So now what I'm going to do is hit enter, and what that's going to do is it's not going to commit the labels, but it will add it to that existing label ID number 16. All right, so where the restriction tool comes in is I can now assign this label that I just painted to a very specific already existing label. So I'm going to hit Shift R, and I'm going to click on a point underneath the label that I want to assign to that ID. So as you can see, I now applied label ID 16 to this pre-existing label. And this can come in handy when you want to either separate existing segmentations, like for example, outer mitomembrane to inner cristae, or you want to reassign part of the endosomal network to something like exit sites. You can find quite a few applications for this tool. And so now if I hit Control C, I would commit these changes to the existing labels and the Paintera canvas. All right, so now I think that pretty much covers a lot of the basic tools that we use in the CellMap pipeline. So I'm going to hand it over to Kayla to go over how you can upload some visual data and more developmental based features.
Cool. Yeah, thanks a lot for that. Obviously, from the development side of things, you know how you use things, but it's always super informative, I think, to get a intro to the tool from somebody who uses it, you know, more frequently. So let me share my screen here, and I will we'll talk a little bit about some of the things that some of the more, I guess, technical tools, but obviously there's more to talk about. And yeah, if you have any questions, feel free to ask as we go, or I'll try to get through as much as I can. But obviously there's time constraints. So okay. All right. So one of the things that I'm just going to turn off some of these sources because they're we'll get to them in a second. But so one of the things that I wanted to show you is what we have, which are virtual sources. So virtual sources are these sources that they're not, you know, saved to a project file or anything like this. They do some operation on existing data. And they help with visualization in some ways, and maybe annotation as well in certain ways. So one of the things, for example, so this is a rather large data set. It contains, you know, these labels are neurons that are labeled here. So I'm just going to show you one thing. So this data set also has predictions of synaptic cleft distances. So if we turn off the labels for now and we turn on these cleft distances, and we turn off the raw data set. So you'll see, I'll overlay them in a second, but you can see, you know, you have all these cleft distance predictions. Let me just change this to this so you can see them overlaid, and I'll change the color to be green. Okay, so you can see here where these clefts are with relation to the neurons. Right. So one of the virtual sources that we have is called the threshold source. So you go here, sources, virtual, and you can see these two. Threshold is the one we want in particular right now. And it lets you create a source. So you select your raw data, cleft distance. You can select the foreground and the background color and give a min and a max. And this is what the threshold on. I'll click cancel for now because I already have this created, but I'll show you what the result is. Let me turn this cleft distance off, and I'll go to the cleft distance threshold. So yeah, it just creates this binary mask of where the threshold of the intensity of the raw data is within the threshold we define. And you can modify these here on the fly. I can show you if we overlap the two of them, you can see. You can sort of see where, as we zoom in, obviously there's some of that intensity that's outside this threshold. So this is one of the cool things. You can do some sort of fun stuff here. So if I let's turn off the meshes for this here, and I can turn on the meshes for the cleft distance threshold, and you can see some interesting things. It'll try to render all the meshes, all the clefts that it finds in this volume. Obviously, this is probably a little overwhelming, but so this may not be super. Helpful to look through, but something that may be helpful is if you want to look at a specific subset of a structure that is maybe nearby another structure. So this is where the other source comes in. So let me turn back on I'll turn off the threshold for now. I'll turn back on the neuron sources. So we have over here, we have this neuron selected, and you can see the rendering down here. Zoom in a little bit. Right. Anyway, so this is sort of the shape and the mesh settings. The rendering of the mesh you can configure, and I sort of have it configured right now just for being kind of quick, which is maybe why you see some of these disconnected parts. So if you look at the cleft distance threshold, you can see down here, for example, there are some that are either overlapping or nearby, and we can sort of slice through this top section to find some of these. So if we wanted to try to say visualize, the meshes that are connected to this neuron that we have selected, right? So this is something that this connected component can do. So if we go to fill connected components, what it has you do is you select a seed source. So this is the thing we're selecting, in our case, the neurons. So this multi-cut is the name. And then a fill component. So this is the thing you're wanting to determine if it's connected. And so I have this cleft distance special. You give it a name. I already have this, which is why you saw it already. So I won't be creating this, so I'll just show it to you. But right, so you can do this here and specify a color. So let me cancel out of this, but I'll show you what that looks like. So if we turn this off and instead turn on this nearby clefts, you will see. So unfortunately, this could be faster, and I'm using a slightly rather large data set. So that's one of the unfortunate aspects of doing this intersection, and I probably should have prepared a smaller data set, but yeah, so okay, you can see it starting to populate, right? So here you can see it detects the clefts that are nearby, that are connected to this, and it'll go through and it'll connect all of them. So if we turn on the meshes for this, it'll render them, and we can sort of move in and oops. So you can start to see, if I can, the clipping plane is acting up a little weird here. But yeah, you can see this, this mesh here is, this white portion of the mesh is rendering. You just move it closer to the viewing plane of the camera. It's, even for me, it's a little bit, sometimes I don't quite follow how the navigation here should work on it. But right, so you see that it's just detected certain, it's got a neuron connected to a cleft that's nearby the neuron here, another one here, another one down here. And, as you move along, you can sort of see where the other ones are. And you can do some interesting things. I mean, you could turn off the initial mesh rendering for the multi-cut, for example, if you wanted to just view the neurons that are connected to it. So this would be a better way to get a sort of visualization of what is actually connected to this neuron. So these are the two virtual sources we support currently. we want to support more going on, and there's obviously there's always room for more. So if you have ideas that are interesting sort of applications you can apply to existing data, that'd be cool. So I'm just gonna actually get rid of. Well, let me cancel this actually. I'm going to relaunch. I'm going to close this one out, and I'm going to open Paintera again with, because I want to show you some raw data. What it looks like to open some raw data from a remote source. So that is another thing that Paintera supports is loading data from remote sources like S3. And so let me bring this over here and show you what that looks like. Full screen that. Okay, so I'm going to actually show you where I get this data from. So Genelia has hosts this open organelle, which has a lot of cool, like openly available data sets. So this is an interesting one. We can click on this, and you can see these links here. You can also see the S3 location at the bottom. So I'm just going to copy the link here, and then bring Paintera back up. Go File, open raw data. I will just paste the link in here. Make sure it's the right thing. Looks right. Okay, so now you'll see it's loading. So this is it's a really large data set, so it's going to take a little bit to load, but also you have the latency a little bit because it's remote. But also there's and I say a while, I just mean it wasn't as fast as maybe you saw for Alyson. It's not that it's super slow either. And this one also happens to have a lot of data sets. So you'll see when I open this, it just parse a ton of data sets. So one of the things we can do, we can open this. This is some raw data, and it properly parses this metadata because we support the metadata type that this uses. So we can open this. Now this is one that's remote. Two, it's a huge data set, so you're going to see it's maybe not as quick as some of the stuff that you saw with Alyson, but it's fully supported. And obviously, if you want to hone in on a particular region, it will pull in. It would preferentially pull in the high resolution data for the areas you want to look at. Just like it would with the smaller case, but obviously it's a bit more obvious when you have really large data sets. So, and as I'm moving through the image a little bit through the data, you see some of the, you see the sort of the lower resolution blocks come in, and then as they start to load this. So I'm actually going to zoom back out so we can get a bigger idea of the entire image. All right, maybe position over here. Let me zoom in a little bit on the ortho slice. And actually, I'm going to show something. So also in the settings, you can configure the ortho slices to have some transparency. So which is really nice for when we render the meshes. You can sort of see through, and so you can see the 3D structure. Okay, so now I'm going to open another data source. So same one. Let's look at the mitochondria segmentations. So unfortunately, in this case, it did not detect that these are labels based on just the metadata of this particular data set. But we know it's a label, so you can specify it as a label, and that'll tell Paintera how to open it. Okay, so we press OK. So this block, and this box you saw with Alyson as well, but what it's basically saying is if you're importing an existing label data set that it's never seen before, it will ask if you want to generate meshes on the fly. This can be slow, so you can skip it if you don't care about looking at the meshes necessarily. In this case, we want to see the meshes, so we'll just understand that it could be a little slow. So yeah, so here you can see as we go through here, you can see these mitochondria segmentations. We can zoom in. Obviously, you get high resolution as you zoom in. This is interesting. So one thing you can do, so as Alyson said, you go over here to your sources, you can click on the source and you can select it. So this is one thing you can do, and then let me zoom in. So you can see, I guess I selected the membrane specifically, so that's why it's a little interesting in this. As a matter of fact, maybe I'll open a different source of mitoseg, the entire segmentation. It just looks a little cleaner. Let me get rid of this one. This is how you move the source photo. All right, so if I select this, click on this one. So you can see this is the shape, this is the 3D structure of the annotation you have. There's a couple cool tools if you want to select, all of the labels that you're currently looking at. You can do Control-Shift-A. This will select all those labels at the same time. And now you can sort of visualize all of them individually. If you want to, select an additional label, you can right click it to add that to the labels you're selecting. If you just want to clear all the existing selected labels, you can just left click any of these and it will only select that one. Yeah, so then this is all using just remote data sets. So given that these are remote and sort of open source, we don't have write permissions to these, so you can't modify the annotations here. What you could do is if you wanted to, you can create a new label source. I'm sorry, create a new label source on top of this. I'm just using a temp directory right now, but you can populate from your existing label source so you know it has the same data. We don't know that path, but this is fine. And yeah, we can do labels local or something like this, just to indicate that that's where they are. So the scale factors are just the downsampling factors of the different scale levels and their relatives. So, this first one is by 2 in each dimension, by 4, by 8, so on and so forth. Okay, so we can create this. So now we obviously can't edit this original one, but if you wanted to, you could modify. You could go to local and do exactly what Alyson walked you through earlier. So you select a new, sorry, it's loading the scales, so give it a second. Right, so you can go in here. We selected this one. Maybe you want to, maybe we wanted to refine this. Now, obviously, these are two separate data sets, so you're not, again, actually referencing it, but you can paint in here, and then maybe later you want to merge these or something. Paintera doesn't currently support that internally, but there's other ways for this. So it's cool. And then you can save this as a project. How to test. Right. So, and then when you open this next time, it will have references to the remote sources and to the local sources as well. And it will combine these so you can do a visualization as well as the local annotations. Yeah. So there's, I think, it's a little bit past 11, so I think I'll stop there. I'd be happy to take any questions on if there's anything about that. Yeah.
Thank you so much for the presentation. I have a question. It's a technical question. So because
Sure.
Based on the QI, it looks like. So I was confused. Is it a big data viewer QI or NeuroGlancer? Because NeuroGlancer have this kind of 4 views,
Yeah.
but it looks like big data view. So
Right. Right. It uses Big Data Viewer as a library to render, but it obviously does some custom stuff on top of that. Yeah.
Okay, I have 3 questions, but I won't. Okay, Bill.
Yeah, just some basic questions. Could you explain the differences between the fragments and the segments?
Right. So I'll say a little bit, but then I'll let Alyson say a little bit as well. From the developer standpoint, not much really. I mean, you can have a bunch of fragments that comprise a single segment. So if you want to use that for some separation semantically, whether it's based on structure or type of structure or like each mitochondria gets its own fragment maybe, but all mitochondria are the same segment. So that's a little bit of how internally they're sort of treated the same, and they're just like their label IDs. But yeah, I can maybe let Alyson speak to how they work separately for CellMap.
Yeah, for CellMap specifically, we actually took advantage of the fragment and segment IDs. Every fragment, when you generate a new label ID, it'll always have that fragment ID. So we will always keep the same fragment ID, which is also associated with the exact same segment ID. So for example, when you create a new ID, it'll have fragment ID 2 and segment ID 2, for example. And the reason there are 2 IDs, at least in our application, is so that when you go to merge IDs, so if you have several mitochondria, all with different fragment IDs, when you hit control, when you select as many mitochondria as you want and hit control enter, they will all be merged under the same segment ID. So they'll still keep their fragment IDs, which is good for when you want to do refinements or input as training data because you can still individually select the mitochondria, but they will all be pooled under the same essentially segment ID, which can be separate from, let's say, nuclei or anything like that. So the segment ID ties all of one substructure together, essentially.
Yeah, and maybe I should, I can clarify a little bit because I did mention this. When you create a new label ID, right, so a new label ID will have the same fragment and segment ID. The only time you would end up with a situation like what Alyson was describing is if you take two annotations that had separate, that were new, and you merge them together, then they would be merged under a new combined segment ID, but they will exactly, she said, retain their fragment. Yep.
Thanks. I had other questions, but I'll defer to Marwan.
You can go.
Okay, the interpolated, that was pretty cool, like where you're able to do one slice and then you do another slice, you do the interpolation. Is that stuff that's sort of temporary in that it disappears when you hit enter, or is that something that can stick around if you save a data set and go back and, yeah.
Yeah, so I can answer this a little bit. So while you're in interpolation mode, all of that is temporary. Both the interpolated stuff between the slices, but also actually what you painted in the slices. This is all temporary. And if you decide you don't like it, it's really off, whatever, for some reason you realized you did something wrong, you can press escape and that clears it completely. So there's no trace of this anywhere. If you do press enter and you finish this and you find some shape that you've interpolated properly that you like, you made your refinements, you press enter. So so in that case, the data that you have will be there's a couple layers to how Paintera stores the data, but this will still be in it won't be in the data set yet when you press enter, but it will be present on the screen like any of the other annotations. But once you commit those labels, that committing writes that label data to the underlying label data set, and that is so that takes into account the interpolation between the slices. It takes into account the slices. It's all as if you had manually painted those sections individually.
Okay, so like what's actually persisted then onto disk is just your fragment IDs and your segment IDs.
Exactly.
There's no notion about the, like you painted a few manual interpolations and those are also, those are just temporary.
Right.
Yeah.
Right. And actually, to be a bit more technical about it, it's the label data. Yeah, those are persisted on disk. The data set itself does not contain the separate fragment and segment. I have to check which one. It only contains one of them, and then there's a mapping that Paintera has also in its project data set so it knows what fragments are part of what segments and so on.
Great.
Yep.
Other question is meshes. So I think you pointed out that when you're doing like S3 or block-based sources that they can generate the meshes on the fly a little bit slower. Was all the mesh stuff that we were seeing before, was that all on the fly, or are there pre-computed meshes?
You can, I believe, import meshes, although it's not something I've done much. But the main time when you use pre-computed meshes is if it's a Paintera project that you've had around for a while. Maybe you've generated these in a previous session or something that's persisted into the Paintera project. And so when you or if you want to, I guess, import somebody else's Paintera project, also this can have that mesh information. So it will generate those. It knows those are generated. We'll just use those. But yes, I think Alyson can correct me if she's wrong, but certainly all the new data sets that she was creating did have that.
Yeah, it was kind of cool. I think I noticed that you also had a feature there where you could define sort of a range or nearby or something, and then it would just create the meshes for that. Yeah, that was nice.
Yeah, that's the virtual threshold source, and that's kind of nice if you, I showed it for distances based on intensity values of Cleft predictions, yeah.
That's all for me.
One basic question. When you create a new N5 dataset, what is the block size?
I would have to check by that. I can check quickly.
I think when Alyson did it, we saw that unless it was default, it was like 64 cubed.
Yeah, I think you can configure it, but I think that's probably true. Yeah, I can look it up while we continue.
I've got a quick question for Alyson. How often do you commit stuff?
I think best practice would probably be, it kind of varies for me. That's something I'm kind of trying to standardize a bit, but I generally would do that maybe after every large interpolation that I do, because it does also seem to help speed up annotations as you commit as well.
I have a question for Alyson too. So usually right now, when you start annotating big data, so you split it between annotator, and so you start by the script that create crop the N5. So the area that you take, you finish the whole area, or how do you split annotation between you?
So far the solution to that for annotating a bunch of large data at once across different annotators is the cropping those large N5 data sets into smaller data sets and just manually tracking which coordinates and dimensions are used. But eventually it would be nice if we could all tap in to like a large N5 raw data set and annotate at the same time, but at different regions or lock different regions. So yeah, I think that's something that could be eventually in the works.
Yeah. Any more questions?
Okay, yeah, so I've got another one for Alyson then. I guess what I'm curious about is like, I guess how large of a brush you use and whether you do more, like I can imagine I haven't done as much annotation as you, but like when I do stuff, I'm sort of torn between working with a big brush and then kind of overdoing it and then erasing the parts that I've overdone versus like using a small brush and being extra careful and then like filling in the middle, if you know what I mean. So I guess I'm curious where on that spectrum you lie most of the time, or like, I guess, what do you find most efficient in terms of that?
I guess now that the new interpolation tools are available, whereas before it was going in and out of interpolation mode and you had to be a little more careful with your boundaries, especially where in training data, it's really critical to include all of those membranes and not kind of underestimate those boundaries. But now it's almost more efficient to overestimate anyways, because kind of cleaning up a little bit and erasing during the interpolation now quickly shrinks your selection down and gets rid of any of those overestimated spots. So I think it's a lot better than building back up. So I'll generally use like a larger brush, especially in shape interpolation mode where flood fill isn't available. But either way, I think I kind of lean towards the larger brush size and depth as well.
Has there been any work on sort of like snapping kind of features? I think like in some of the other Photoshop things that you can kind of paint, but that it kind of expands or snaps to some sort of gradient, or is that too problematic?
There is nothing currently like this by now. What I can say is that some of the more recent updates have been targeted at making it easier to develop like additional tools for Pantera like this. So there's nothing like that now, but I do think it would be something useful and cool to have. So we're always open to ideas. I think that's something that would come in handy, definitely. But yeah, no, at the moment, there's nothing quite like it.
Question and comment. Question first. Alyson mentioned the possibility of multiple annotators working on a single N5 volume and like potentially locking parts of the file. Have you guys explored how you would do that yet technically? I've had some reasons to try and lock blocks from ZAR files on the cluster, and there's actually a bunch of technical hurdles to doing that. So I was wondering if you guys had tried and found anything.
So from my side, I can speak to saying, no, I don't think we have. I guess what I would suggest if you wanted to do something like that would be to do some hybrid approach. So you have this single raw data source you open that is shared in a read-only mode. So you don't worry about this, just the raw data, and whether it's remote or whatever. And then you create your label data set on top of it in a particular region. So your label data set is smaller than the entire image. And then each person could have potentially a different subset that they're working with. And then you're writing into individual data sets. But yeah, so I mean, so it doesn't really, it sort of just is a hybrid approach. It doesn't really solve the issue of writing simultaneously, which I think would be a nice and useful feature. But yeah, as far as on this sort of things, I think that's what I would suggest currently. But you know, if there was a way to do more simultaneous writing, I mean, that would be a really cool feature to have. I think if you could lock certain areas.
Yeah, I think if you can guarantee that annotators are working, that nobody's writing to the same blocks, then you don't have to lock any files anyway, because there's never going to be a concurrent write problem. But like the NRS and DM11 don't support file locking based on how they're built. So like I've talked to Ken and Rob about this, about like workarounds. It would require like looping them in on every single time you would want to open a data set and work on it. So if you want like a really general thing that locks blocks of the ZAR file, you have to either implement the blocking yourself in your code instead of at the operating system level, which I've tried to do using like some Dask tools, because that's, for me, my workers weren't annotators. They were like, you know, different Dask workers. And I was trying to make sure that each Dask worker wasn't trying to write to the same block of a ZAR file at the same time. And even in using some of the pre-built Dask-based tools for locking chunks of, chunks of write targets, it was still really a pain in the neck. So maybe it's easier in your guys' case because like the annotators are humans and they can decide like, okay, we're gonna not work on the same part at the same time. You can't really guarantee that when the computers are doing the job. But if you did go for a fully general solution, there's a bunch of issues and problems associated with it. And okay, so I had a comment too about the snap to thing. Just like how I would be thinking about that if you were going to build it is probably just a local level set in 2D, because they're at any point in time, they're annotating some 2D plane, right? So you just take that plane, whether it's orthogonal or oblique, and then just take like a reasonable crop around the edge of the brush stroke, and then run a quick level set algorithm. You could probably make that appear almost real time, like less than a second. If your crop is only like 128 by 128 or 256 by 256, you could do 200 iterations of a level set algorithm in 2D, like in less than a second. I really like this Python-based level set package. So it wouldn't be so useful in a job application, but the underlying algorithm is like extremely simple. So you could rebuild it, called morph snakes. It's really cool. It's based on like a level set implementation that doesn't, if you know level sets, they like solve a bunch of differential equations. And so historically they're pretty slow, but this replaces all the differential equations with morphological operators like erosions and dilations. And they have a bunch of proofs in the paper about it, about how like you convert to the same result. It's a really neat paper, and I use morph snakes all the time for stuff. So I think that would, if you were going to pursue that feature, that's how I would start it.
Yeah.
So awesome.
Yeah, this is definitely something we've talked about on and off. So yeah, I look into it. That's really cool. Thanks for the tip.
So you said you can take annotations from another software and import them into Paintera to work on. Can you take Paintera annotations and export them back to that original annotation software?
So I can say something quickly, which is that it depends on your metadata. If your metadata originally is something that Pantera understands, then you shouldn't have a problem. But maybe Alyson can give you a bit of a more concrete example of something she's gone through.
Yeah, so luckily Amira has a N5 reader and writer, so I think it could really easily take some of those N5 label data sets from Paintera and potentially convert them into TIFFs to use directly in Amira. So yeah, that's definitely something that can be used for.
So, but is it working now?
I haven't recently tried, but I think it does work now. I think the main issue right now is taking some N5 written labels from Amira, bringing them into Paintera, and then getting the correct offset of the raw data to use alongside those label N5s from Amira. But the other way around should work okay.